Have you ever wondered if the most terrifying threats to humanity are from aliens or asteroids, but from the very ground beneath your feet? What if those hidden dangers are not fictional monsters, but real slow-motion natural forces, quietly reshaping our world? You may be startled to learn that Earth's greatest threats are invisible processes woven into the planet's own fabric. And by the end of this video, you will understand how these silent doomsday machines could change everything. Stay with me until the very end, and I promise you will gain a deeper respect for our planet's immense power and fragility. Earth is alive with activity that happens on timescales far too slow to notice in a single lifetime, yet powerful enough to reshape continents and climates. These phenomena are hidden from daily view, but potent beyond imagination. We often consider threats that arrive quickly and visibly, but the most profound dangers operate gradually underground or beneath oceans, quietly storing energy or shifting environmental baselines. These natural systems have operated for millions of years before humans walked the planet, and understanding them is vital to our long-term survival. Consider ancient oceans turning lifeless. In periods known as oceanic anoxic events, the seas lost oxygen, suffocating marine life on a global scale while releasing toxic gases and disrupting climate patterns. Massive layers of black sediment mark these intervals in Earth's history, corresponding with major extinctions that reshaped evolution. Scientists have confirmed at least 5 such events during the Phanerozoic Eon, each associated with catastrophic marine die-offs and ecological collapse. One contributor to these events is methane clathrate deposits stored on the seafloor. Under pressure and cold conditions, methane becomes trapped in ice-like structures, but warming oceans can destabilize these reservoirs, releasing large amounts of methane gas, a potent greenhouse agent. This process is sometimes called the clathrate gun hypothesis, because a rapid release could amplify global warming, causing ocean temperatures and currents to shift drastically, triggering feedback loops that devastate marine ecosystems and even accelerate ice melt on land. Ocean currents themselves are sensitive to temperature and salinity changes. The slowdown of thermaline circulation, such as the Atlantic meridional overturning circulation, could alter heat distribution, intensify regional droughts, and change rainfall patterns worldwide, all silent yet transformational. Beneath the land surface, supervolcanoes like Yellowstone, dormant for tens or hundreds of thousands of years, accumulating magma in vast calderas. When they erupt, they eject thousands of cubic kilometers of ash and gas into the atmosphere, causing years of global cooling, crop failures, and ecosystem collapse. Yellowstone's magma chamber spreads beneath much of Wyoming and Montana, and its last eruption approximately 630,000 years ago literally covered North America with ash. If such an eruption recurs, it could lower global temperatures by several degrees for years, drastically reducing agricultural productivity and threatening food security globally. Another hidden risk is the gradual reversal of Earth's magnetic poles, a flip in the magnetosphere that occurs every few 100,000 years. During reversals, the magnetic field weakens for thousands of years, allowing more cosmic and solar radiation to reach the surface. This could impair satellite communications, damage power grids, increase cancer risks, and degrade ozone layers. Geological records confirm multiple reversals in Earth's past, but no mass extinction is linked directly to any known reversal, though the cumulative effects on modern technology and civilization could be severe. Yet another slow danger is slow slip earthquakes, in which tectonic stress is released gradually over days or months along fault zones, a process invisible to most early warning systems, while loading strain on adjacent locked fault patches that may then rupture in sudden megaquakes. Scientists have measured these slow tremors in places like Cascadia and Japan, and they show that seismic risk is not only about sudden quakes, but also about these creeping ruptures that alter stress patterns in ways we still don't fully understand. Then there is the atmosphere itself, shaped by subtle yet powerful processes. Runaway greenhouse effects akin to Venus's transformation remind us that atmospheric composition is delicately balanced, and even moderate increases in carbon dioxide can drive a non-linear heating trend if feedback loops amplify warming. Venus transformed into a near-boiling inferno because water vapor created a strong greenhouse effect that accelerated its heat retention in a positive feedback cycle, and Earth's future depends on staying below critical thresholds for such acceleration. Major volcanic eruptions contribute aerosols like sulfur dioxide that eject into the stratosphere, reflecting sunlight and cooling the planet for up to several years. But prolonged high aerosol loads can trigger global dimming, reducing crop yields, altering precipitation, and impacting ecosystems worldwide. The cooling effect may seem beneficial, but if sustained could disrupt monsoon systems and hydrological cycles, leading to famine in vulnerable regions. Atmospheric composition also relies on a balance of greenhouse gases, water vapor, particulate matter, and ozone. Disturbances in this balance, like methane spikes or ozone depletion, can shift climate systems enough to trigger mass ecosystem reorganizations or potentially collapse agricultural zones. All these forces operate on timescales from thousands to millions of years, but their cumulative effect is profound because they shape continents, seas, climate systems, and biodiversity in ways sudden events cannot. We often feel safe because these processes are slow, but their impact spans across generations, making them silent giants that operate beneath our daily awareness. Understanding these phenomena places humanity in a geological timeline that dwarfs our individual lifespans. Our place is small but responsible, because awareness allows adaptation and mitigation strategies. If we learn how ocean currents change, how methane reservoirs destabilize, how volcanic systems evolve, and how atmospheric chemistry shifts, we can develop predictive models, early warning systems, and sustainable practices to coexist with these forces rather than be overwhelmed by them. Geoengineering measures, careful carbon sequestration, global cooperation, and robust monitoring networks provide tools to mitigate some of these risks. But science also cautions that interfering with planetary systems must be done carefully to avoid unintended consequences. We must humble ourselves before Earth's immense, silent power and respect the ongoing evolution of our world, because these aren't fictional threats, they are real and ongoing. Our survival depends not only on confronting visible crises, but also on understanding slow planetary machines that could reshape our world in subtle yet catastrophic ways. Thank you for staying until the end, and I urge you to ponder these hidden forces. Subscribe for more explorations of Earth's silent power, like this video, share with others who marvel at our planet, and comment your thoughts below. Which process surprised you most?